Assalamualaikum. We continue this session with the topics of ion chromatography. If we look at this picture, the instrument of ion chromatography is quite similar with the HPLC, but they have some difference in aspect of principle of separations or mode of detection. So it can be teach separately from the HPLC. IC is adapted to the suppression of ions and polar compounds. Compared to the HPLC, is more tend to separate the different types of polarity of analyte. And basic principle of ion chromatography, this chromatography techniques is concerned with the separation of ions and polar compounds. So the stationary phase will contain ionic sites that create dipolar interaction with the analyte present in the sample. Means the stationary phase have a charge. If a compound has a high charge density, it will retain a long time by the stationary phase. This is the difference principle where true HPLC is based on the polarity of the analyte with the stationary phase. For ion chromatography, it based on the charge density of the ions. The more charge density, the more longer it will retain on the stationary phase. This exchange process is much slower when compared to those found in the type of other chromatography. Separation principle of IC is ion exchange. It can be ion pair formation or ion exclusion. If these two, it become more specialized application, we can apply these two separation. So now we just focus for the ion exchange, where if we want to separate the analyte of a cation, which is the positive charge ion, so it must be cationic column. Cationic column here must be negative charge. The silica, the stationary phase must be in the charge of negative inside this cationic column. For the analyte to be exchanged, for example, the negative charge ion or anion species, we have to use the anionic column, which is the charge of this column is positive charge, which is the things that keep on exchange is the negative species. That's the principle of IC, where the stationary phase and the ionic keep on changing. Now we go through the schematic diagram of the ion chromatography. It looks like same, which is the first one is mobile phase, and this mobile phase will pump by the pump system, and we have to inject our sample. Both our mobile phase and our sample will pass through the column, and after pass through the column, it will have a different retention time and it will be detected by the detector. The difference here, it can be via suppressor or can be direct. The difference between other chromatography like HPLC is the detector is based on the conductivity of electric by the ion. For the HPLC, they use the PDA, which is the UV light range. So the chromatograms looks like this, whereas the x-axis will be time and the y-axis will be the conductivity of the electric. This is the schematic diagram. If it looks like this schematic, is not much different with the HPLC. Now we go for the each compartment, important compartment in the IC. The first one is stationary phase, means column of the IC. Like I mentioned just now, for the anion exchange chromatography, means the things that keep on changing is the negative ion charge. Our analyte is negative ion. We want to have the peak for the negative charge ion, so our column must be positive charge. And for the cation means our analyte is positive charge. The one we want to have the peak is the positive charge ion. So our column must be negatively charged. So requirement for to be a stationary phase must be narrow granular, monodisperse of the size, and large specific surface area, mechanical resistance, stability under acid and basic pH, and rapid ion transfer. This is the criteria needed for the stationary phase for the IC. Now we go for the different type of material for stationary phase in IC. Mostly it based on the polymer base. Best known stationary phase issues from copolymer of styrene and divinyl benzene. This is the material inside the stationary phase for the IC. Normally for HPLC we use what? We use the silica gel. For cation separation, the cation exchange resin, the material inside the column is usually a copolymer surface with sulfonate functional group, strong acid cation exchange. This is for the cation exchange resin. And copolymer with carboxylic acid functional group, this is for the weak cation exchange. And the material for the anion separation means negative charge ion. So the surface of the stationary phase must be positive charge. So that's why for copolymer surface is quaternary ammonium. Ammonium is positive charge. Functional group, which is a strong basic exchanger. And for copolymer with amine functional group is known as a weak basic exchanger. And this is how the stationary phase of IC cross section looks like. If you can see, for cation exchange resin is used sulfonate. And for the anion here, we can see the polystyrene for anion exchange resin is here for amine group. And quaternary ammonium group, you can see this one is quaternary, this one is the one keep on constant on the surface of stationary phase, and the one is keep on exchanging is the negative ion. This is for anion exchange. That's why they call anion exchange. The one that keep on exchanging is the negative charge. The one cation exchange resin mean this one, this sulfonate resin we keep on constant on the surface of stationary phase, and the one that keep on changing or exchange is the positive charge. Another things, rather than that materials, silica based materials also can be used, but it must have a covalent bonding of alkyl phenyl change of sulfonate group, and quaternary ammonium group can be attached to the silica gel. The similar how to attach the this R functional group is same as the silica phase developed in HPLC. And this is the copolymerization of monoethylenic monomers, which is they remain the properties of this one, and it will not longer be ionized in any form. And other than a silica material of silica gel, resin films also can be used by a monomer contain inorganic groups, deposit on the beads, and waterproof support to form a continuous layer 1 to 2 micron thickness, and microsphere silica or glass polystyrene about 25 micrometer diameter. This is if the material is the resin films. This is the size. And this is how they coating the films resin with the charge. You can see the ionic coating on the latex surface, and this is can be used of one of the material for the stationary phase in IC. And this is the common ion exchange resin. If we want to have a cation exchanger, we have to use the for the surface must be sulfonic acid and carboxylic acid. Means the one that keep on change is the positive charge. The material must be in the form of negative. The material, this one is shows the material or the charge on the surface of the stationary phase. This one shows us the analyte that we are going to exchange. And this one for the anion, if you want to keep to have the peak for the anion or negative ion, our stationary phase must have the positive charge. Here it shows you quaternary amine with a strong base. If you have to, the sample is a weak base, we can use amine functional group for the surface on the stationary phase. That's about the stationary phase. Now move to the next part, which is mobile phases. Most of IC must use aqueous with organic or inorganic buffers, means it use buffer solution. Analytic and functional group at stationary phase will be ionized in the eluent. That's why they need the buffer solution. We have the positive or negative charge ion. And this is the mechanism of the anion separation. We will see both mechanism for anion and cation. What happened when the sample is injected and interaction with the mobile phase and also stationary phase. Okay, so now we start with the first mechanism. Anion, if the anions in a mobile phase, now we attract at the resin of our stationary phase. Stationary phase in equilibrate with the mobile phase. Now mobile phase have the negative charge, it will equilibrate with the resin, which is resin is the positive charge, because what we intend to separate is the anion. Now, so the sample ion is absorbed on the active sites of the stationary phase to displace the mobile phase ion. Now our sample have negative charge. What we tend to get the peak is the negative charge ion. So means the negative charge ion from the sample or anion from the sample will keep on exchange with the negative charge from the solvent or mobile phase. Here stationary phase is the resin with the positive charge. Here show you the positive charge resin, the surface of your stationary phase. Now this is negative charge is from your mobile phase. Now your analyte is fighting with the negative charge from the mobile phase. Now it keep on exchanging. Ion in mobile phase compete with sample ions, and sample ions are eluted out. Now when the ion in a mobile phase compete your sample ion, and sample ions cannot be retained anymore on the surface of the resin, it will be displaced out, it will be eluted out. So that's why ions A are eluted out. So we have the peak of A. Let's say ion B now compete with the negative charge from the eluent. After elute compound A, compound B, we have the second peak, followed by the third peak, fourth peak. All these anions are in the sample. That's the mechanism of anion separation. Now move to the mechanism of cation separation. Same goes to the cation, which the stationary phase must have the surface of the negative charge, and the one that keep on changing is this positive charge. So that's why mobile phase should have acids, which is positive, and this acid will keep on changing with the positive charge ion. And when the positive charge ion cannot retain anymore on the surface of the stationary phase, it will be eluted out. So that's have a different peak. And the last part is the conductivity detectors. Based on the electrolyte conductivity, most of the detector in the IC is about the conductivity of electric, because ion have a electric charge. That's why the measurement of the detector is based on the conductivity of electric, and can perform direct or indirect. Direct measurement is single column. If indirect measurement, ion suppressor. It are used to increase the sensitivity. This is the detectors used in the IC based on the conductivity of electric. And we go for the first single column IC, also known as non-suppressed ion chromatography. In order to do direct measurement, the ionic charge of mobile phase has to be low as possible, and measuring cell requires strict temperature within 0.01, because the high dependence on the conductance of the temperature. That's why they need to control the mobile phase should be low possible, and because this is non-suppressed ion chromatography, the detector must be able to detect small change of eluent conductivity. if the use a single column ion. If use the ion suppressor, what is the purpose of having ion suppressor in IC? The mobile phase contains ion that create a background conductivity. That's why when the mobile phase give us some conductivity, it's difficult to measure the conductivity due to the analytes, only to the analytes as they exit the column. So it will be disturbed by the conductivity of the mobile phase. That's why they have to pass through the ion suppressor. What is the function of ion suppressor? To improve the signal to noise ratio, the ion suppressors is used to selectively remove the mobile phase ion, and it will be placed after the analytical column and before the detector. What is the principle of ion suppressor? To convert the mobile phase ion to a neutral form or replacing by other of higher conductivity. So the signal that come out only come from analyte, not from the mobile phase. That's the function of ion suppressor. So we can see the cation suppressor. What is the function of cation suppressor? And this is a cation suppressor. So our resin is in form of here our resin is a positive charge. So now this positive charge will trap our positive charge with trap of the resin from trap the Cl negative from the mobile phase, and now the analytes that come out is only for the positive charge without disturbance of the negative charge from the mobile phase. This is for cation suppression. For the next anion suppression, same mobile phase, it will be disturbed by the positive charge here. Now it will trap the positive charge from the solvent. So now the one that's come out is only the signal from the negative charge from the analyte, not from the solvent, because this one had been trapped. Sodium had been trapped by the suppressor. So suppressor, what is the difference between suppressor and non-suppressor type? So non-suppressor type is simple system, easy maintenance, low conductivity mobile phase. For suppressor type, low background current, high sensitivity, system is more complicated. This is the chromatogram, whereas when the have suppressor, they will increase the conductivity for the first initial start for a run, because they want to suppress the signal of the mobile phase. And now this is the peak, and this is if we use non-suppressor type. And selectivity of ion, how the peak or how the elution order will be predicted based on this factor. The first factor is because of the valence ion. The more ionic charge, the more retention time. For example, if the cation, I want to separate the cation, we have calcium, sodium, potassium. The one have positive charge will be retained more longer, means this one have a longer retention time compared to the potassium. Same goes to the anion. Sulfate with the 2 negative is more longer than the fluorine. This is the first factor. Second factor is radius of hydrated ion. If the radius of hydrated ion reduce, so the retention time increase, means between lithium and sodium, lithium radius ion is more smaller than sodium. That's why lithium is come out first compared to followed by the sodium. Same goes to this one. Fluorine will come out first and then followed by the chlorine. Next is the factor is polarization ion. The more the ion will be polarized, it can easily has longer retention. Means the more it can be polarized, it have a long retention time. So means SCN negative is more polarized than SO4 to negative. So that's why SCN is more retained on the column compared to the sulfate ion. Next factor is the concentration of mobile phase. The more concentrated the mobile phase, the more ion concentration. So the retention time will be reduced. And column temperature, the higher the temperature, the lower the viscosity of the mobile phase. So more theoretical theoretical plate numbers and the lower retention time. The last factor is pH, whereas the pH lower than 4 degrees, so undissociated weak cation exchanger. pH more than 8, dissociated weak cation exchanger, and pH between is partially dissociated weak cation exchanger. And this is the elution order, like I mentioned just now. Because of the size, fluorine is smaller and more charges will be more longer. The sequence is like this. It cannot be just simply say why this one. They have their own factor. Like cation also have a reason why lithium is come out first compared to the calcium. So the chromatogram will be separated based on the what you are running, because you have to run separately unless you have a Dewey column. Now they develop a Dewey column which positive and negative charge can be run simultaneously. But if you use a different column, you have the different peak. Like this for the cation, this peak is for anion. They have 2 injection system and 2 different columns and 2 different mobile phase. And common application for the IC, normally we determine the inorganic anions and cations. And for environmental analysis in water, we want to know positive and negative charge ion. For quality assurance, for the water and pure water, determination of ionic composition, separation of compound, and purification of components from the mixture. That's all for IC. Thank you.